In this video, I'm going to show you how to make a pass network with real soccer data and the Python programming language. Okay, so what is a pass network? At a basic level, it's a visual map of how players connect to each other through passing. Each player is represented by a node, and these nodes are placed based on where the player tends to receive the ball or play the ball on average. Then the lines are drawn between two players to show passing connections. The more often that two players connect, the stronger or thicker the line can be. So instead of just looking at a spreadsheet of passes, what you get is the team's total structure relating to passes during the game. Okay, so I've actually created a video here which takes every 10 minutes during the game and updates the information. So in the beginning, we can see that the nodes are a little bit more disconnected. The players' nodes are actually smaller and the lines are less thick. And as we gather more data, we can see how this evolves over time. All right, so now that we know what a pass network is, let's go take a look at the data required to make one. The way that most event data works is that there's going to be one row per event, and it's going to have all this metadata attached to it that you can actually filter out. Event data typically has a subtype, which is the event type. And for this particular data set, we're going to be interested in player possession, because what this data actually does is it gives you another subtype, which is an N type, pass. The other bits of information that we need are going to be the location of the passer, who they're passing it to, and the location of the person that they're passing it to. We want the event type. We're going to filter by event type, and then we're going to filter by N type. Then we're going to filter by the pass outcome. We're going to want the team short name, and we're going to want the player name, which is what this passer column is, and we have the player targeted name. The way it works is that down the center here, this is 0, 0. You can think of this as a coordinate plane. And let's just say this is negative 20 meters, and then maybe another negative 20 meters, and that's the location. So negative 20 for X, and then negative 20 for Y for Hall. Let's go back to an actual pass network for Newcastle. And we can look at this and determine what we need from our data set. So the first thing being the average location. And the way I did this is anytime a player passed the ball or received the ball, I took those numbers and averaged them together to find their average location. The next thing is going to be the node size. So we can look at this player right here as a smaller node than Nata. And the reason being that they have a smaller node is they made less passes, so their count. The final thing that we need is going to be the relationship between these players. So anytime two players pass to each other, we added a number in to count that relationship. We're going to create two different data frames here. First for the passer locations, and then for receiver locations, we're going to take the targeted player's name and their X and Y locations as well. We're going to concat those two data frames together right here. And then we're going to start finding our aggregate numbers. So we're going to group it by player name, run the mean on X, the mean on Y, and count the number of times they appear for each player. And then once we've got to the average locations, we've got a player name, their average location, and the count of their touches. All right, I think this is what is so interesting about sports analytics, is that When you watch a game, you can come up with a hypothesis, but we know as humans we're flawed and that we have biases. With data and technology, we can capture data and then test those hypotheses to see if we're right. A merge is no longer just a merge. It becomes the geometry of a team, and a group buy is no longer just a group buy. It becomes a relationship between two players, and that to me is fascinating. The next part, we're going to look at the pass links and how we build those. So what was the relationship between the players? And now that we have our data frame, we actually want to start building the link part. And that's the line in between two players, the relationship. We're going to do that by taking our original pass data frame, grouping it by the player who passed and the player that received. So this is where we actually link it. We have pass links, and we're going to merge that with the average locations on the name, the passer. And that's just going to result in our data frame that we created right here for pass links with our previous average data frame right here. We're going to take our data frame right here, and we're going to merge again so that we can eventually have a data frame that has the location from and an average location to. After linking our data, we draw the field. I won't spend any time on this, but you can copy the code if you'd like. Okay, so the next thing we're going to talk about are scale helpers. And what that does is take the nodes and the line width, and then we scale them to the size that's appropriate for the passes. So these nodes are going to be bigger or smaller depending on the amount of passes they made, and these lines are going to be thicker or thinner depending on the relation between these two passers. So our scale width is going to take in a value and then a min-max value, and then we're going to scale it between those two numbers of the min and max. And the same thing for the scale size. And this is going to be by far the most complicated bit of code that we have. First thing we're going to do is go through draw pass lines, and we're going to iterate through each one of these rows that we've created. We're going to take the minimum and the maximum of the pass count. So if we imagine over here that this is our full data frame, the minimum is going to be 3 and the maximum is going to be 12. So that when we create one of those lines, we're going to say that 5 is a little bit bigger than the minimum, and 4 is a little bit smaller than 5, and 7 is about midway, and 12 would be a really large, thick line. In addition to the thickness of the line, we're going to make each line opaque or not opaque. It'll be opaque if the line is thin, and it'll be more dark if the line is thick. This just helps with visualization. Finally, we're just going to do a scatter plot for all the X and Y values right here. Moving on to the nodes, we're going to do something very similar. So now that we have both of our pass networks, let's take a look at them and see if we can derive some information. And this is going to require some contextual knowledge from my previous videos, so if you haven't watched those, you can go watch them, but I'll try to explain it here. The first thing that I see right away is that Newcastle were really pinned into their own half, which is pretty damning when we know that Auckland FC actually won the game 2-0. And from my previous videos, we saw that a lot of the passes that Auckland were able to orchestrate were in these half spaces. And a half space runs long ways on either side of the field right here. And then on the outside, we have the outside space that's called a lot of different things, and then the center space. But Auckland SC, from my previous videos, they were making a lot of their passes right in here, which makes sense when we actually see the pass network. We can see who was actually involved in it. And as well as the passes, they were also making the pressures in these areas as well. So there's probably a whole lot of high turnover and then immediate passing and directly working towards the goal. All right, so the next thing that I want to point out is that the defenders will typically have a high pass rate, and we can see that's true for both teams. And that makes sense. From watching games, we see that defenders tend to pass the ball back and forth here until they can find a way to progress it forward. What the pass network actually helps us do is see where those passes were happening. So while Newcastle had about the same kind of pass rate between the defenders, they didn't do it very far up the field. They were still pinned in their final third, whereas Auckland were passing with 2 defenders, and it looks like fullbacks were pushed up a little bit higher, and they were still getting a high pass rate. So pass networks can tell a fantastic story, and they give us a lot of information that's very clean on a page. But I'm going to show you how you can actually make the pass network a little bit more interesting and show a little bit more of a story. And that's simply by binning each 10 minutes of the game to create their own pass network for each part of it. And what this will allow us to do is add another feature to our data, which is time. And we can see how our pass networks evolved over time. You can see if a team was really progressive in the first half of the game, but their average was dragged down by the second half of the game. And I'm just going to scroll through Newcastle's, and then I'll go through Auckland's so we can see the difference between the two. And what's actually interesting about this is that we never see it past the other part of the field, but we also see that there's a lot of disconnection. So the front 3 players right here aren't getting any passes to them. And throughout the game, it's just disconnected like that. And that's endemic of a team that's not doing well. We'll do the same for Auckland FC. And even though the majority of their passes are going to be in this area with the defenders, they're starting to make some pass networks that are up the field. And this is a really good example of what Newcastle was not doing. They were not having strong connections between players further up the field and linking from the defenders up to these players as well. So pass networks are a fantastic tool, and they can tell you many things, but there are some caveats. They don't tell you necessarily everything that you might want to know, such as off-the-ball runs or whether a team was effective in their passing. How many times have we seen a team dominate possession, but they were outdone by 2 quick counterattacks? And though that wasn't the case for these 2 teams, you need to keep that in mind when you're looking at a piece of data. But they are a fantastic lens into specific parts of the game.